Hello. We've been talking about multiple regression and how we select the independent variables that we want to include in a model. And generally, this is done through some sort of stepwise procedure. We can do forward selection, where we add variables one at a time and see what effect they have on the model. But this is an example of a process called backward elimination, where we're going to start with all the potential independent variables and eliminate them one at a time until we have a statistically significant model. So I'm working with data from the National Football League. I've got all of the different teams in the NFL and some statistics that's been collected from the 2007 season. So we're interested in points per game. That's going to be our dependent variable. That's what we're trying to predict. And in order to predict that, we think it might be useful to look at some of these other statistics. So we have yards per game, rushing yards per game, passing yards, opponent rushing yards, opponent passing yards, penalties, penalty yards, interceptions, fumbles, passes intercepted, and fumbles recovered. So we have a number of different statistics here and data that's been collected that we think might help us predict points per game. So the first thing we should do with multiple regression is check for multicollinearity between these independent variables. Are any of these independent variables highly correlated? To do that, we use Excel's correlation tool. So in the data analysis tool pack, we find the correlation tool and open it. And our input range is going to be all of our independent variables. So we don't want points per game. That's a dependent variable. We take all of our independent variables, include labels as our input. It is grouped by columns. I check the box that I included labels, and I'll put it in a new worksheet, and I'll name that worksheet correlation. Say OK. So here's our correlation table. I'll just adjust the columns. Most textbooks will tell you that any correlation coefficient above 0.8 is problematic as far as multiple regression. We should not include two variables that have a correlation coefficient greater than 0.8. So I start looking through all my correlation coefficients. I've got a 0.846 here. So that's going to be a problem. I've got a 0.93 here. Everything else is under 0.8, but there's one that sort of stands out at 0.72. I'm just going to highlight that one as well. So if we go to, this is a 0.93 is a high correlation between penalties and penalty yards. Right? Penalty yards and penalties. That sort of makes sense. So I shouldn't use both of those variables in my model. Penalty yards might carry a little more information than penalties, so I'll probably drop penalties. If I come to this first one, the 0.84, that's a high correlation between yards per game and passing yards per game. So if I look at the data I've got here, I have yards per game, rushing yards per game, and passing yards per game. Yards per game is just going to be a total of the rushing yards per game and the passing yards per game. So we can see where some of this information is sort of duplicated here. So if I have to eliminate either yards per game or passing yards per game, if I eliminate yards per game, then I still retain all the information because I've got rushing yards and passing yards. Now we come to this 0.72. So that's between opponent yards per game and opponent passing yards per game. So it's the same sort of relationship. And so to be consistent, I would eliminate opponent yards per game as well. It has a high correlation, and it is also just the total of opponent rushing yards and opponent passing yards. So I'm going to eliminate 3 of my variables: penalties, opponent yards per game, and yards per game. Now I've copied my original data here into, I've just copied that sheet into what I'll call a working copy, because I'm going to start eliminating variables. So I said I was going to eliminate yards per game, so I will delete that. Opponent yards per game, I'll delete that. And penalties. I'm keeping penalty yards, so I'll delete that. So I'm down to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9 independent variables. The 10th one is my dependent variable. So I have 9 variables that I'm going to start doing multiple regression analysis. So I'll go to Data Analysis Toolpack, find my regression tool. Okay, so my Y range is points per game. This is my dependent variable. This is what I'm trying to predict. My X range is going to be all of my independent variables, all 9 of my independent variables. I've included labels. I'm going to let it go to a new worksheet. So I'm going to call this worksheet 9 variables. I'll ask for, I won't ask for residuals and residual plots yet. We'll look at what we have left at the end. So I'll say OK. So I've got my output here for my regression model. R squared is 0.867, so about 80% of all the variance in points per game is being explained somewhere in this model. I have a very small significant f, so I'm very confident that that R squared is not 0. Certainly much more than I need for a 95% significance level. But that doesn't tell me anything about each of the individual independent variables. For that, I have to look at my p-values. So I have 2 independent variables that have p-values less than 0.05. None of the rest of them do. And in backward elimination, I'm going to eliminate the one with the highest p-value. So the one with the highest p-value this time round is passes intercepted. So we'll eliminate that from our working copy. So I'll go back to my working copy. I'm eliminating passes intercepted. So I'll just delete that column. And now I'll go and do my regression analysis again. So my Y range hasn't changed. The only thing that has changed is now instead of going to column K, I go to column J. So I can just replace K with J. Labels are the same. I need a new worksheet title. So this is now with a model with 8 variables. I'll say OK. And we'll go and look at the results. So again, now still lots of variance being explained. There's a good model here somewhere. my p-values, I have 2 that are less than 0.05, and I find my largest p-value, which is opponent passing yards. So I'm going to eliminate opponent passing yards. It's having the least effect on my model, certainly not a statistically significant effect. So I go back to my working copy, eliminate opponent passing yards, delete that column, and we go through the process again. Call up the regression tool. Now instead of column J, we're only going to column I. We now are dealing with 7 variables. Say OK. So the 7 variables, we still only have 2 that are having a significant effect. I eliminate the next highest, so the next highest one is penalty yards. So I'll go back to my working copy, eliminate penalty yards, and do another analysis. You can see how this goes fairly quickly. So instead of I, now I'm at column H, and I'm dealing with 6 variables for my worksheet name. My p-values, I still have 2 having a significant effect. My highest now is 0.22, which is fumbles. So I will eliminate fumbles from my data set. So we'll take out this column. Get our regression tool back. H becomes G. And we're now dealing with 5 variables. Say OK. Two variables still are having a significant effect. The largest p-value is opponent rushing yards, so we're going to eliminate opponent rushing yards next. Back to the working copy, opponent rushing yards, we'll delete that column, and get our regression tool. Data now only goes to column F. And I've got 4 variables. And look at my p-values, very small, very small. And now interceptions has become less than 0.05. So at a 95% level of significance, we would say it's having a statistically significant effect on our model. Fumbles recovered, however, has a p-value more than 0.5. It's the largest, and we will eliminate it on our next round. So fumbles recovered comes out of my data set. Delete. And hopefully for the last time, we will do our regression tool. So we now go to column E. And we have 3 variables. I'm going to ask for residuals and residual plots this time. Or actually, I'll just ask for the plots. That's what I'm going to look at. I'll say OK. Oh, yes, I can say OK. And here we are. So let's look at our data. So R squared, this model is accounting for 80 83.5 or 84% of all of the variation in points per game. We are very confident that that is not 0. Looking at the significance F as far as the total model itself. As far as independent variables, we look at our p-values, and the p-value for rushing yards is very small. For passing yards is very small. For interceptions is still well under 0.05. So at a 95% significance level, we can say that all 3 of these variables are having a statistically significant effect on our model. We'll check the residual plots for each of those variables just to see that we're looking for nice random patterns. No particular pattern, just a random scatter, and all of those residual plots look good. So this is our final model.